Measures of central tendency. That's like you want to think about the center of something. So one such measure is the mean, something that you probably have seen and may not have been aware of it. It's the same as finding the average of something. So when you see this notation, this X the line over it, I'm just going to say that that's X bar. It does represent the mean in statistics. So this is like a statistics section. This funny looking symbol is a sigma, capital letter S in the Greek alphabet, and it just means sum. Now this X, or this N I mean, is the number of data values. And then these individual X's, X1, X2, dot 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 dot, Xn, they represent the individual data values. So you're going to add up all the data values and divide by how many values that you have. Add and divide by the number of values. So that's what that really means. So for example, let's find the X bar of this example. So we'll take 87 plus 98 plus 65 plus 99 plus 54. And how many values do we have? 1, 2, 3, 4, 5. So I just divide by 5. I'm going to bring up my calculator. I'm going to type these in. 87 plus 98 plus 65 plus 99 plus 54. And we get 403. I'm just going to divide that by 5. Probably get 80.6 if I had to guess. And that's your mean. While I have the calculator up here, watch this. See that stat? I'm going to click on stat. I'm going to keep it on edit and just hit enter. Then I'm going to type in these data values here. 87, enter. 98, enter. 65, enter. 99, enter. And 54, enter. Then I'm going to hit second mode, which is the quit button. Takes me to a plain screen. Going to hit stat. Going to go over to calc. Leave it on the one var stats. That's one variable statistics. Hit enter. That will pop up. Hit enter again. And you see the X bar 80.6. So something just to be aware of. Use it if you want. Now this example is a little bit different because it's in a chart form and you're given the frequencies. What that means is it's the number of times that the data values are used. So for example, this 34 and 2, that means that there's two 34s. And this 54 and the frequency of 7, that means there's 7 of those. They get all 7 of them. 1, 2, 3, 4, 5, 6, 7. Just so you be aware of something, this 34 plus 34 is 68. It's the same thing as 34 times 2. And then if you add up all the 54s, it's the same as 54 times 7. So when you do the 6's, it's the same as 21 times 6. And then 87 times 1. If I were to write them all out, I have 6 21s and 187. So how many total will I have? Well, 9, 10, 16 total. So to find the mean, I could list them all individually like I did the first two. Or I could just do the shortcut. 34 times 2 plus 54 times 7 plus 21 times 6 plus 81 times 1. And then divide that by the total, which is total frequencies. 2 plus 7 plus 6 plus 1, which you already know is 16. We already saw that. So let's take out our calculator. And let's just do 34 times 2 plus 54 times 7 plus 21 times 6 plus 81 times 1 is just that same thing. We get 653. And we want to divide that by 16 to find the mean. which is about 40.81 if you round up to 2 decimal places. Now if you do want to type that in your calculator using that one feature, go to Stat, Edit. I guess you have to just type them in individually. I'm trying to think if there's a shortcut way. Some calculators there's a shortcut way. The TI-86s, which have been discontinued for quite a few years, there was a shortcut way. I'm trying to remember if there was one here. Otherwise, watch this. If I go up, hit clear, bring it back down, clears those numbers out. You might just have to type them all in individually. $34, enter, $34, enter, and then so on, so on, so on. Blah, 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 blah. I don't want to do it all, but you get the idea. Hopefully. If you don't, do it by hand. Can't go wrong with by hand. Now here's a real life problem. In a certain company, 25 people earn $20,000 a year. 2 earn $45,000 and 1 earns $550,000. Find the mean salary. Is this realistic? What that question is, if someone were to ask you what's the average salary for this company, would what I'm about to find be representative of that company? So we got 25 people that earn how much? $20,000 per year. We have 2 people that earn $45,000 per year. We have 1 that earns $550,000. So how many total people do we have that work at this company? We have 25 plus the 2 plus the 1. So when we add these up, 25 times 20,000 plus 2 times 45,000, just so you can see, and then plus the 550,000 person. So you get that big number. 1, 2, 3, 4. Divided by 25, 26, 7, 28. So the average salary is $40,714.29. So if someone were to ask you, does that represent what you expect to make at this company? The answer is no, because you would really expect to make around 20,000, since 25 out of the 28 people make 20,000. So you probably have a couple supervisors and 1 owner that make the other money. So this doesn't really represent what you should expect to make at the company. It's too high. It's actually double what you might really expect to make. A better indicator might be something called the median or the mode, which we'll talk about that later. Median just means the middle value. If you ever see a capital letter M, that represents the median. So there's some rules here. To find the middle value or the median, you must arrange the values in ascending order from smallest to largest. Keep that in mind. Have to do that first. If you have an odd number of values, the middle number is your median. If it's an even number of values, then you have to average the 2 middle numbers. In this little bitty formula, n plus 1 divided by 2, n is the number of data values, plus 1 divided by 2, will only tell you where the median can be found. It doesn't tell you what it is. It tells you the position of it. So let's look at this example. These numbers are already in order, which is always good. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we can find the middle number, that means we'll be good to go. I like to use this position formula. So if I do 11 plus 1 divided by 2, that gives us 12 divided by 2, which is 6. There's no number 6. It doesn't mean even if there were, that still won't be the median. It's just the 6th value from the left. So 1, 2, 3, 4, 5, 6. So the median is 67. And the reason is because you have 5 numbers in front and 5 numbers after. It's the one in the middle. Now in this example, it is not in correct order. So I need to put in correct order. So we'll start with a 3, and then we have an 8, and then what do we have next? A couple 33s. I put them both in there. And then we have a 44, and a 56, and then a 67, and then a 76, 98, and 102. How many values do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values. So I'm going to use that position formula again. 10 plus 1 over 2. 11 over 2 is 5.5. So what that means is it's between the 5th and 6th values. 1, 2, 3, 4, 5. So it's between these two numbers. It's right in here. So to find the median, you would take 44 plus 56 divided by 2, which is 100 divided by 2, which is 50. That's the median. It does not have to be a data value itself. So right here is your median. So if you count it in front of it, 1, 2, 3, 4, 5, you have 5 values, 1, 2, 3, 4, 5, and 5 after it. So 50 is right in the middle. That's your median. Now this one's a little bit more complicated. In fact, we saw this in the mean example. For the median, I could actually list these out. And I really don't want to, by the way. But I can, but I'm not going to. Even though it looks like I am. I'm not going to. I don't have to because of that position formula. So when I count, when I add those up, I mean, if you want to list them all out, that's fine. I just don't want to. So when you add them up, 7, 8, 9, 10, there's 16 values. So 16 plus 1 divided by 2 is 17 divided by 2. And 17 divided by 2 is 8.5. So it's between the 8th and 9th values. And I may end up having to list them all, but see if you can follow along. So if I actually were to list them all, or start listing them, the first two numbers will be 34 and 34. And the next ones will be 54, 54. Because there's 7 of these. So 1, 2, 3, 4, 5, 6, 7. Now stop right there. It's between the 8th and 9th values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is actually in there. Between those two. If I want to add them all up, but before I could do that, notice I did something wrong here. Anybody catch it? That wasn't correct order. Did you catch that? Because I should start with the 21. See that? Correct order. So it should have been 21, 21, 21, 21, 21, 21. 1, 2, 3, 4, 5, 6. And then the 34, 34. And then the 54, 54, dot, dot, dot. The reason why I don't have to do them all because I'm looking for the 8th and 9th values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's in between those two instead. Gotta watch that stuff now. It's all about the order. So what that means is to find the median, I will now take 34 plus 54 divided by 2. And that is 88 divided by 2, which is 44. So the median is 44. Now I didn't have to list all of this. I could have come up here and rewrote this in correct order. 21, 34, 54, and 87. And then 21 had 6, 34 had 2, 54 has 7, 87 has 1. So if I'm the 8th and the 9th, I can see that I have 6, 7, 8. So my last 34 is the 8th position, and the first 54 is the 9th. So I haven't write it all out. Just by counting 6 plus 2 is 8, and then one more is 9. So the 8th one's 34, and then I will start writing the 54s like I did here, which means I would use 34 and 54 to find the median. Or, like I said, list them all out in correct order. Quartiles. All quartiles do, they divide it up into 4 sets. And to divide something up into 4 sets, well, how many breaks do you need? Well, let's see, that gives me 3 sections, 1, 2, 3. That gives me 1, 2, 3, 4. So that's 4 sections. Well, this is Q1, that's Q2, and that's Q3. Q2, if you take a good look at this, it's the actual median. So what you're going to do is you're going to find the median of all data values, and that's going to be your Q2. And since we are dealing with medians, you have to write them in correct order first. So once you write them in correct order, find the median, and then you're going to find the median of this list. And then you'll find the median of that list. And so let's do an example so you can see how this works. First thing is I need to put this in correct order. 4 is the smallest number. Looks like 18 is the next one. 21. We have a couple of 23s, so write both of those down. And then it looks like we have a 44 and then a 45 and then 52 and then 54 and 76. How many data values do we start with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you want to do first is find Q2, which is the median of all the data values. Since we have 10 plus 1 divided by 2 is 5.5. So 1, 2, 3, 4, 5. So Q2 is right in there. It's the average of those two numbers. So it's 23 plus 44 divided by 2. And so let's just take out our calculator, since we have one. 23 plus 44, which is 67, divided by 2, 33.5. That's our Q2. Now Q1 is the median of those numbers. Since there's only 5, and this one's fairly easy to see, that is your Q1. It's the one in the middle of the first 5 data values. And then Q3 is the median of the numbers after Q2. And it looks like it's right there, 52. So if you look at it, we have 25% of the values there, you got another 25% there, another 25% there, and another 25% there. That's what that means. So 75% of the data values are less than 52. Approximately 75% of the data values are less than 52. So it gives you an idea of how to divide it up into 4 quarters, in other words. Now, on this box and whisker plot, it has a 5-number summary. That 5-number summary has the 3 quartiles and then the minimum and maximum values. So let's just go ahead and write all these down while we have them. So let's start with the quartiles. We're doing the previous example. Quartile 1 is 21. Quartile 2 is 33.5. And quartile 3 is 52. That was from the previous example. Now the minimum is just the smallest value, and the maximum is the highest value. So the minimum value is 4, and the highest, or the maximum, is 76. So we have enough information to draw a box and whisker display. So there's a couple ways you can draw it. I'm just going to draw a very basic one. I could use a number line, A lot of times you're supposed to use a number line. I'm not sure if your book does or not. But if I do use a number line, if I think about, it's actually better to use a number line even if it doesn't. If I were to like to count by fives, try to space them out as evenly as possible. Or maybe I should even count by, let's count by tens because I'm running out of space. So let's just count by tens. Because the highest number is in the 70s, so I'm afraid I might have run out of space. So here we go. To do this box and whisker plot, we're going to draw a box. Q1 and Q3 are the edges of the box. That's where you start with. 21 is about right there, and 52 is about right there. So there's your box. So that's Q1. That's your Q3. Now Q2 is 33.5. So I'm going to draw a line. I'm going to use a dotted line. I'm not sure what your book uses. It doesn't really matter. But that's your Q2. Then we got whiskers. So we got a minimum of 4. So I'm going to put a little whisker right there. And extend it like that. So that's your min. Then your max is 76. So that's going to be about right there. Box and whisker display. It makes it a lot easier to see how to find information. For one thing is you can see that you got 25% data values that are in that range, and then 25% in this portion of the box, and 25% in this portion of the box, and 25% in this whisker. So it makes it a little bit easier to find information. Before I go to the mode, I got to show you something with your graphing calculator. So let's go back to stat, enter, let's clear that out, let's type these numbers in. I'm just going to actually take the original numbers as they are, type them in, not worried about the order. 18, 23, 45, 21, 4, 76, 52, 23, 44, 54. Then hit second, quit, go to a plain screen, hit stat, go back to calc, 1 var stat, so I can hit 1 or just hit enter again. Now I'm going to show you something. See that arrow? That means there's more stuff down there. See the minimum? 4. See the Q1, 21. Median, which is the same as Q2, 33.5. See that Q3 is 52. Max 76. There's your 5-number summary. What do you think about that? Yeah, thought you'd be impressed. So just keep that in mind. Modes. Modes are the values that occur most often. Doesn't mean they occur more than once. It just means the one that occurs most often. And in this book, you're allowed to have up to 2 modes. If it has more than 2 modes, that's the same as saying no modes. So let's look at this example. We have 3 1s, 3 2s, and 4 3s. So the mode is the data value of 3. It has nothing to do with these down here. Nothing at all to do with those. It's the value that occurs most often. The 3 occurs most often. So that's why the mode is 3. Let's look at this one. We have 3 values, 3 1s, 3 2s, 1 1 and 1 each. So that means our modes in this case are 1 and 2. Those data values occur 3 times each. Now this one we have 2 1s, 2 2s, 2 3s. That's too many modes. We can't have 3 modes. 3 modes not allowed. So the answer is no mode. So mode's fairly easy, so don't get hung up on that. And that's it.